Alright, what we're looking at next is how to solve radical equations. And here's a little help from the book. It says solving radical equations containing nth roots. If necessary, arrange terms so that one radical is isolated on one side of the equation. Raise both sides of the equation to the nth power to eliminate the isolated nth root. Solve the resulting equation. If the equation still contains radicals, repeat steps 1 and 2. Check all proposed solutions in the original equation. So a couple things. One, we want to isolate our radical. We want to raise it to whatever degree or whatever to the degree of the index. We want to basically see if there's still a radical. If not, we have to repeat the process. But 4 is also very important. Check the proposed solutions in the original equation. Now, what we've been working with is different equations, and some of our equations actually basically gave us an extraneous solution, or the chance for an extraneous solution, because we had variables in the denominator. Well, this is another case where we have the possibility of having an extraneous solution. So anytime you see a variable under a radical, make sure that you check your answer. So let's see if we can't follow our little rules here to get our answer. So as you can see, we have this radical. The square root of 2x minus 1 plus 2 is equal to x. So first thing we want to do is we want to isolate our radical. So I'm going to go ahead and move this 2 to the other side, and I'll get the square root of 2x minus 1 is equal to x minus 2. At this point in time, as you can see, we have our radical isolated. So what we're going to do now is we're going to square both sides. If we'd squared both sides in the original problem, it would not have gotten rid of our radical, because this would have been a monomial, but here you would have had a binomial. So this times itself is going to be fine, but this times this is going to be 2 square root of 2x minus 1. So it's not going to get rid of our radicals, so that's why we want to isolate it. When you square this radical, you get 2x minus 1. And then squaring this binomial, just a little reminder, the way you square a binomial is you're going to write it twice and multiply it together. And when you do that, you'll get 4 terms, but 2 of those 4 terms are like terms. So we should get negative 4x plus 4. Now, as you can see, by squaring both sides, I actually got rid of my radical. So what I'll do now is I'll go ahead and solve for x. I mean, just kidding, not solve for x. I want to isolate, or get it set equal to 0. Best way to say it. I always like my leading coefficient to be positive, so instead of moving everything over here, I chose to move everything over there. So that's just something I like. Hopefully you can find your own preferences when you're working on math problems and go from there. At this point in time, what you can see, as you see, we have a quadratic equation. So if we're solving a quadratic equation, what we need to do is we've got different methods. We could do solving for x if there's only one variable. We could factor if it's factorable. If not, you can always use completing the square or the quadratic formula. On a problem like this, though, I would actually use factoring. So I would say negative 5 and negative 1. So x minus 5 and x plus or minus 1. When you set both of these equal to 0, you'll get solutions. X is equal to 5 and x is equal to 1. Now, like I showed you on that last thing, you need to make sure that you check your answers. So when I plug 5 in, this will give me 10 minus 1 is 9. 9 plus 2, or the square root of 9 is 3, and 3 plus 2 is 5. So as you can see, that one works. When I plug in 1, I get 2 times 1 is 2, minus 1 is 1. The square root of 1 is 1. 1 plus 2 is 3, not 1. So this is actually an extraneous solution. So even though I found 2, only 1 works when I plug it back in.